Hello, chemistry students. We kind of skipped an earlier chapter, chapter 3, so we're going to go back and cover that now. It's a lot of scientific notation, which I know you've talked about before, and most of you probably know what that is, but we have to go over it and some other concepts along with that. So we're going to review how to write numbers in scientific notation. We're going to talk about accuracy and precision and what that means in science. And then we're going to explain why measurements must be reported to the correct number of significant figures and actually what that means when I say significant figures. But first, a quick review of what it means to measure something and a quick review of scientific notation. So measurement is a quantity that has both a number and a unit. And in science, we have to always make sure that we're expressing those units. Like, I can't say I am, I can't say I am 100 and I'm just making up numbers. I'm 150 tall, right? That doesn't mean anything. So what units tall am I? So we always express that number and also what unit we're talking about. Scientific notation is a means to express either very large numbers, like how far away a star is from Earth, or we might how far another planet is away from Earth, or something along that magnitude. How many bacteria exist in Dower Lake? That would be a really, really large number. So rather than say, oh, Dower Lake has this many bacteria in, that takes up a lot of space and it's not very efficient, and we probably don't need all those zeros because we probably didn't measure every single bacteria in Dower Lake. So we're kind of saying, this many as an approximate number. I'm going to go in and put so I can see where I am. A much easier way to represent this is scientific notation. So scientific notation always has one number before the decimal. That's always the right way. So it's going to be 5.7 times 10 to the something or other. And how do we know what that exponent is? I simply count. So here's my decimal. Remember, whole numbers have an understood decimal. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 5.7 times 10 to the 11th. This is a much more efficient way of writing this very large number. And again, in science, we use really large numbers really a lot of the time. We also use really small numbers to express things that are very tiny. So if I want to talk about the length, and I'm just totally going to make a number up here, if I want to talk about the length of a bacterial cell in, let's say, meters, it's probably going to be something like, actually I'm going to say centimeters because even that, I have no idea, I'm just making stuff up. 1, 4, let's just say centimeters. Again, I'm sure this is totally not accurate, but I'm just using this as an example. So this would be my bacterial cell size. This, again, takes up a lot of space. If I want to write this in scientific notation, I can write it as 1.4 times 10 to the, now I'm going the other way, and that's important to note. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I went to the right, and it's a really tiny number. So this becomes 1.4 times 10 to the negative 10th power. So that's the difference between whether it's positive or negative. If it's a number greater than 1, your exponent will always be a positive number. If it's a value or a number less than 1, we're moving that decimal to the right instead of to the left. Less than 1 is always going to be a negative exponent. So there's some interesting ways that we can save some time and do some estimations if we understand how to add and subtract using exponents. I know I've had students in the past who say, well, I always, if I have to add and subtract, I move them out of scientific notation and then I'm just adding and subtracting the whole numbers. And that's a huge unnecessary extra amount of work. It's actually pretty simple. So in addition and subtraction, the rule is you convert whatever you're adding or subtracting to have the same exponent. So if I'm adding 1.5 times 10 to the 5th with 9.9 times 10 to the 5th, these exponents are the same. So I just carry down the 10 to the 5th, and then I add my whole numbers together, and I get 11.4. Have a little bit of a problem here because remember I said, the correct way to write scientific notation is one number before that decimal. So this isn't in correct scientific notation. So I need to move this decimal. So I'm going to take this 11.4 times 10 to the 5th. I need to move this one decimal place over. I just made this number smaller, so I need to make the exponent one number larger. I moved it one place to the left and made this smaller. My exponent must increase. So 11.4 times 10 to the 5th is the exact same number as 1.14 times 10 to the 6th. On this bottom one, we are subtracting, and I'm going to have to convert one of these to the same exponent. So 1.97 times 10 to the 8th, I can it doesn't matter which one I change, I can do whatever I want. Just know that if I want to convert this one to 10 to the 8th, I made this exponent larger, this number has to get smaller. I'm kind of thinking ahead. In order for my answer to be in correct scientific notation, probably makes more sense to convert this bottom one to 10 to the 8th, because otherwise I'm going to try to take 0.97 minus 2.5, and then I'll have to convert exponents in the end, if that makes sense. But it doesn't matter. You just save a step if you could kind of see that in advance a little bit. So I'm going to make my change to this one. I'm going to change this to times 10 to the 8th. I made this larger. I have to make this one smaller. Okay? So this now becomes 0.25, and then I can just subtract 7 minus 5 is 2, 9 minus 2 is 7, carry my decimal down, and I have 1.72 times, and then I'm just going to carry, they're both 10 to the 8th at that point. So hopefully that makes sense. What I actually did was I took 1.97 times 10 to the 8th minus 0.25 times 10 to the 8th, and this is where I got 1.72, in case this looks messy and you can't follow, times 10 to the 8th. All right, so those are the rules with addition and subtraction. And just remember, after you complete your calculations, is this in correct scientific notation? Yes or no? And this one actually is, so I don't have to do what I did up here where I had to kind of convert that.